You're welcome to this new episode. Today we want to look at composite functions, a continuation about functions. Don't forget to subscribe. If you're given a function fx and a function gx, then we say that function f gx is a composite function. It's a composite function where we perform the function gx first, then followed by the function f. So like when you have a function f gx, we say you can first I can put this in these big brackets. Like you evaluate, you first find gx, then after getting gx, come back and feed it in the function of a function f, which is given. So you're given two functions, and then we say a combination of these functions is what we call a composite function. So you need to remember also that when you have f gx, it is not actually equal to gfx. Like gfx, we perform fx first, then followed by g, as we are going to see in the examples. Let's look at examples right away. Given that fx is equal to x plus 3 and gx equals to x squared, find. Let's look at a as that, b f gfx, then c fg1. So if you're given two functions fx and gx, then you're required to find a composite function fgx. What do we do? So let's find fgx. We're saying that this is the same as fgx, something like that. Like first get the function of get the function gx, feed it in the function f. Okay, so like this is you take it as if you're finding f of something here, but whatever is here, you substitute it where there is x. So if we know our fx as x plus 3. Okay, but now we want to find f of gx. Okay, so what is our f gx? We know this is what is gx? Gx is known as x squared. So meaning in this function of fx, where there is x, let's put x squared. So meaning this would actually be equal to x squared, where there is x, we put x squared plus a 3. Let's see part B. If you want to get gfx, then this one we are saying it's the same as this. Okay, so meaning we are going to substitute fx in the function of g. Okay, so what was our gx? Our gx is equal to x squared. So meaning if you want to find this, if we are finding g of fx is the same as g what was fx, we substitute this function in the bracket, so our fx will be, it was x plus 3. Alright, so we gone, we already know that our g of x is equal to x squared, so meaning our g of x plus 3, which is the g fx, is equal to, where there is x we put everything here, so like x plus 3 squared. You could go on and expand, but I'm going to leave it at that. Let us look at more examples. Example 2, given fx as 3x, then gx as 4 plus x, then hx equaling to x squared minus 1, then find, we're required to find Roman numeral 1, f of gx, Roman numeral 2, to find gf of x, Roman numeral 3, to find hfx, Roman numeral 4, to find hfgx. Yeah, let's look at those ones. Let's start right away. Roman numeral 1, want to find f g of x. So we say this is the same as getting gx and you substitute the function of f. So we can write it as this so that we can see it properly. Get gx, substituting the function of f. Okay, so meaning this is the same as f of what is gx. Gx was 4 plus x. So refer back to our fx. Our fx is equal to 3x. So if you want f of 4 plus x, then where there is x, because this is x, meaning this is taking the position of x in this function. So meaning even here it will take the position of x, which is 4 plus x. We can leave it there. Okay, Roman numeral 2, g fx. We are saying this is the same as g of fx, like we are substituting a function fx into a function dx. So meaning we want to find g of what is fx. Fx is 3x. So remind yourself what is gx, because you want to substitute in gx. So but gx is equal to 4 plus x. So meaning if you want to find g of 3x, we compare. This 3x is taking a position of x, okay, in the function g. So meaning in this function where there is x, we shall put the 3x to get g3x. So meaning that our g fx is equal to a 4 plus the position of x we said is taken up by the 3x. Okay, so we end up with that. Look at Roman numeral 3, hfx. This one we set the same as hfx. Okay, meaning we are substituting a function x in h. So meaning we want h, what was our fx? Our fx was 3x. Okay, So remind yourself what was your function hx. Function hx was x squared minus 1. So if you want to get h3x, which is this, okay, they are equivalent, then we are seeing that this 3x is taking a position of x in this function. So where there is x, we put 3x. So we have 3x squared minus 1, okay, which we can write like this is a difference of two squares. You can set the same as 3x plus 1 into 3x minus 1. Alright, let's look at lastly one number 4. This is hfdx. Okay, so it is easy if we first consider these, like we consider when you're working out the composite functions, we always start from the right. So let's first consider these two. Okay, let's first find f dx. Then after getting that, we shall come back and apply it here. So what is f dx? We are saying that this is the same as f d of x, which is the same as f. What was dx? Actually, we already have this. Yeah, f dx. We already have it. But maybe just remind ourselves. This is what was dx? Dx was 4 plus x. And we got our f dx as get a function of x, I mean fx, which is 3, then into x, but our x now is occupied by this. So this is our f dx. When we have that function, we take it now to this. So like we have h f dx, we are saying it's the same as h, a function of f dx, but we know what this is. It is 3 into 4 plus x. Okay, so meaning if you have a function of h, which is x squared minus 1, then h of, let me open this to give me 12 plus 3x is equal to, where there is x, we put 12 plus 3x. So this is 12 plus 3x squared minus 1. We can expand to give us 144 plus 72x plus 9x squared minus 1, which is a quadratic expression 9x squared plus 72x plus 143. Yeah, that is about the composite functions. Thank you for watching. Don't forget to subscribe, to share, and to comment. See you.